About the line of best fit. We've seen the line, or the trend line as you would call it sometimes, before in the scatter plots. Let's have a talk about what that line is and what it does. The best line of fit is the line that minimizes the distance between actual data points in your scatter plot and the line. And it therefore gives us the best possible relationship between the two or more variables. We use the line of best fit so that you can observe trends, make predictions, and understand the relationship between the variables you're looking at. So here we see an example of a scatter plot again. We've got some data plotted on a y-axis and an x-axis, and we've also plotted the mean of the dependent variable. To fit the line of best fit, what we do is we fit the mean line, which is obviously your worst possible line you can get, which would be a relationship of 0, and then we continue trying to fit. We work out the difference between the actual data points and that line. Now this is the worst possible line. This is not the line we want because it gives us a relationship of 0. What we do is we try to find a line that better represents the data. So we'd try and fit a new line, and again we do the same. We measure the distance between each value and the line. Again, this is something the computer does for you, and it'll try and fit the absolute best line by working out the distance between your data points and that line. Interestingly, it does also work for independent variables that are ordinal or categorical. It does it in using fancy maths, but the idea is similar, although we do interpret it slightly different. So rather than having a line like this, where we say it's strong when something is positive or not, if you go back, what it does is it gives us the difference in mean. So between male and females, it works out what that difference in mean is and whether it is strongly correlated or not. So in this particular case, we have men and women, and there's a difference in mean in 1.15. We'll cover that in the next week, but essentially what you're doing here is you're using regression and you're getting the output of an ANOVA or a t-test. So the line of best fit gives you a value, which is the slope, and we call that R, or correlation coefficient. You can see examples here when we have a strong R, so strong correlation is when everything is very close to the line, and it's positive when it goes up from left to right. Again, we can have a strong negative correlation, which is when the slope goes down and everything is close to the line. If the data points are really widely dispersed from the line of best fit, then we can obviously have a positive or weak correlation again as well. Now, let's look at some terminology that you will come across. The most obvious one is residuals. What are residuals? Residuals are essentially the distance of the data point from the line of best fit. And later on, when we talk about assumptions, understanding what the residual is important. 3 more errors that you will come across are the sums of squared errors. The sums of squared errors explain the variability of your data. And these sums squared of errors and the other 2 terms I'll explain later are used to calculate R squared, which helps you understand how good your model is. Why do we square these terms? Well, if we have a line and we have things falling above and below the line, some will be negative values, some will be positive values. So to ensure that they don't cancel each other out, we square the values. So the sum of squared errors is the error mean is essentially the residual. It's the number that represents the distance from the line and the actual value. The sum of regression represents the distance from the mean of y to the regression line. so slightly different. And then the sum of totals represents the difference between the mean and the actual value. With this said, you now should have a good idea of how the line of best fit works, the things that some of the terms that we might use that you come across, and you'll also have learned why these are important.